So we are not Learning Milan. In a group of people now here, it's just me and Marco. There.
Hi.
Guys, if you want to sit near Marco, don't worry. You don't bite.
I don't bite people.
Yeah. Okay, so.
Sorry.
Yeah.
You're right.
So we are meetup in Milan, and our goal basically is like to spread machine learning and all, like, let's share all the story, all the use case, all the industry applications that are shared in Milan. But our main goal is like to, let's say, have a European view. So we get in touch with many international groups, and in the next steps we actually want to bring more people from all Europe in Milan, just to show what's happening out there and what people are doing here. And we have a profit group, so that's why we find the different locations. Today we are in Y, and we want to thank you a lot of them. I actually work in Y, it's a great company. And yeah, we are a partner from this year in YAM. It's basically an Italian association for machine learning. What they do is they try to combine all the groups of like small folks like me and Marco together. And we try to organize a bigger conference at least once a year. And that's why we joined them. We think it's a cool project. We actually can spread our ideas. So yeah, we joined it. Then, yeah, what day is today? Is yeah, it's P-Day. Wow. But that's actually who you are. It's like 1,000 people. It's our group actually got this milestone from Meetup. And it's great for us. Like, we got many interest from people. That's why we want to foster like events, foster like activities like this one, just to show that something is happening in Milan and something can be changed. And yeah, that was the actual slide. Yeah, and then yeah, another update, which I don't remember now, but Mark is help me. Yeah, so we did a questionnaire like to some of you who were already registered before, and we find out who are our participants, who are you, basically. So 45% define themselves as beginner, and our goal basically is like to try to bring these people into intermediate. How we do that? Like we actually try to do these events, share stories, and try to inspire people to study more, get to develop by themselves the tools. And so we just released a link, and then when we show the slides, we'll show you in the next slide. Basically, you can find a Google Doc, which a lot of mock or like books. You can actually, whoever of you is interested, we're going to show you this, and you can actually study whatever you want, like Python, R, or whatever. So, next slide today is Giorgio from Specification, the guy there. He works in Y. And then Pietro La Torre, which is
Hi.
yeah. So, what's going to happen today, basically, is going to explain a use case about fraud detection, Giorgio, and then Pietro is going to show a pizza detector. Probably you are only for the pizza detector guy, right, guys? Mm-hmm. Yeah, I guess so. Yeah. So now I want to call Giorgio, which will present his application and how we do it. Thanks, Giorgio. Hello, good evening, everyone.
What's this?
Yeah.
Pitch time?
Right. It's pitch time. All right, so tonight I will discuss with you a practical use case about fraud detection. And, okay, I will briefly introduce you to the goal of this application, context and the framework. And I will focus on the fine-tuning challenges that I faced throughout the development of this machine learning application. So, if we jump to the next chart, let's start straight with the goals.
Do this, and
okay,
I
will do this and you.
Yeah.
Okay. So what are we going to discuss? A machine learning model that helps the anti-fraud specialist of a major Italian bank to better detect fraudulent transactions. And this is based on a true story, meaning that this model is being deployed in production right now, and it's a real practical use case. Now, just to make the ground clear and make sure we are on the same page, this is a binary classification problem. We will classify with 0 a legit transaction and with 1 a fraud transaction. We will build a predictive model. So the output will be a probability between 0 and 1, and we will classify a transaction as a fraud if the probability is greater than 0.5. How do we evaluate the performance of a model? Of course, we have evaluation metrics.
We have two numerical evaluation metrics, the ARA under the ROC curve and the F1 score. If you know what they are, good. If you don't, the higher the better. And then we have the confusion matrix, which is always a bit confusing. So I would like to discuss it with you before we jump into the content. This is what I've been working on. So confusion matrix with the actual class here and the predicted class here. We will see true negatives on the top left corner and true positives, so frauds, real frauds that the model was able to detect, on the bottom right corner. We will pay a lot of attention to this number here. These are false negatives. It's when the criminal won. These are frauds that the model was not able to detect, and this is a very dangerous error for the bank. Now let's go with the context and our framework. The bank has a rule-based engine which is able to detect suspicious transactions. So every day this engine would highlight roughly 5,000 transactions as suspicious. But on average only 14 of these transactions are real frauds. So this means there's a lot of manual work to identify real frauds. Now you might have a guess, this is a very unbalanced data set. If you look at this picture, the green transactions are the real frauds, and the gray C is all the suspicious transactions. Now, this gives us a data set with 6 months of historical data and counting, because we're adding every month, one by one, of course. And roughly 500,000 observations, of which only 1,000 roughly are actual frauds. So once again, very unbalanced data set. The duration is actually 2 frauds over 1,000 transactions. From a data set, what we do is feature engineering. We had a very informative data set. We got timestamp of each single transaction, IP address, the amount, the identification of the bank account, some geolocalization, description of the transaction, and we built categorical features, behavioral features, roughly 80 variables. Was it a challenge? No. It's very easy to find online resources on fraud detection and how to build features related. You can look on Kaggle, you can look on Google, of course, you can find university papers telling you how to build informative features. So this is why I'm only talking about feature engineering in this small box, because it was not the biggest challenge in this experience. Now, quickly, why Running Boosted? I chose to use Running Boosted because it's got proven high performance. Comes with a powerful Python package. I use the Extreme Running Boosted to boost. It's kind of a plug-and-play tool, so you don't need normalization, and it is robust to missing values. And of course, it's an area of expertise in my team and colleagues, no better than Stack Overflow. So it's one more good reason to choose Running Boosted. Now, first I'm lucky. It's a plug-and-play tool, so what I did is get my data and plug it into the Python package, see what happened. This happened. I got a model which gives me back this confusion matrix, which means the model signals as frauds 49 transactions, it identifies 39 frauds correctly, but then we miss 297 frauds. So imagine an anti-fraud specialist which, with this performance, he would get fired. So what happens with this model? It belongs to the recycle bin, and it gives us 4 challenges for fine-tuning. We will have to handle the unbalanced data set to do some hyperparameter tuning. We will work with a small model ensemble, and also we will tune the threshold of our model. Let's go with the unbalanced data set. So it's the case when you have a minority class and a majority class. In our case, the minority class are frauds, and the majority class are legit transactions. You have different ways to deal with an unbalanced data set. I explored the 3 main weights: undersampling, oversampling, and scaling positive weights. What happens with undersampling is that you reduce the amount of legit transaction of the majority class until you match the number of observation in the minority class. So basically, we bring down our data set from 500,000 observation to 2,400 observation. The performance is better. We have to check a lot of transactions, 8,000 transactions roughly, but we identify 300 frauds, and we only missed 32 frauds. It's not bad. It looks good, but we're actually ignoring more than 99% of our data. And it's very unstable because we have to randomly sample from the majority class, and this result would change a lot if we sample with a different random seed. Now, what happens with oversampling is that we do the opposite. We take the minority class and we replicate observations in the minority class until the number of observations matches the number of observations in the majority class. So this gives us a data set which roughly double the size of the initial one. The performance is maybe a bit worse, and the data set size is duplicated. This will slow down a lot during cross-validation and training. Now, the last tool is scaling positive weights. This is something a bit different. We don't touch the data set. We just assign a higher weight to coefficients calculated starting by an observation in the minority class. So this is something that happens through a parameter when the model is trained. The result looks quite good. We are identifying most of the frauds. We don't check so many transactions, and moreover, it's just a model parameter, so the original data is preserved. I don't like this one because it's very unstable. I don't like this one because it duplicates the size of my data set, so this is my winner. Now, moving to the next challenge, hyperparameter tuning. A hyperparameter is a parameter about how the model learns. So it's not the coefficient that is learned by the model, but it is about how the model will learn these coefficients. In XGBoost, Extreme Getting Boosted, you can set more than 35 hyperparameters. Now you can click really fast and then show, go ahead. As you can see, it can be confusing, and you need to find a way to dominate this complexity. For every one of these parameters, you can choose a specific value, often from 0 to infinity. So, how did I do it? I used two tools. I focused on a relevant subset of hyperparameters, and then I tuned them using grid search and cross-validation. Why relevant subset? Because you don't really need all the 35 or more hyperparameters to be perfectly tuned. You can get a very good result with a relevant subset. So what I did is focus first on parameters which help me to handle my data set. So scaling positive weights and picking a subsample of row and columns to feed my algorithm with the... So to address overfitting, because I don't train my model with all the rows in my data set, and to harmonize the features I'm using, because step by step I feed my model with a different subsample of columns. Then these are some technical parameters about the shape of the decision tree. They as well have helped to set the right complexity of the model. So they balance the loss function, they decide how many leaves a tree should have. Second to last, I do ex-post regularization. These lambda and alpha are parameters which impact directly the coefficients learned by the model. They go right into the mathematical formula that specifies those parameters. So I want them to train last because first I want to exploit as much as I can these two parameters here to address the feature selection and overfitting. And in the end, I go to learning rate and boosting iterations, which are very specific for how the model learns. How do I do this training of hyperparameters? With grid search and cross-validation. Grid search means that I select a list of possible values for every parameter, and then I test my model with each value in that list, and I just pick the one with the best performance. Cross-validation means that I split my training data set in some folds, and iteratively I use one fold to test my model and the other one to train it. This is a good, maybe it's even best practice way to train your hyperparameters, and it definitely worked for me in this case. Now, after all of this, the question is, did it work? It did. It did, and this is the result. Before we had a raw model, which wasn't looking too bad. We would check roughly 4% of transactions and identify 80% of frauds, which is pretty good. But if you look at this confusion matrix here, we're only checking 1% of transactions, only not even 1,000 transactions. And this allows us to identify already 70% of frauds. As well, you can see as these two numerical scores that they improved so much from one model to the other one. So this was a very good trick that helped me to improve the performance of my model. Now, Next, naive model assembly. What is a model assembly? It is a technique to harmonize results from different models for you to improve performance. It comes with the cost of a complexity increase, usually, but it can improve performances. I didn't want to pay the cost of complexity increase, so I tried to build a naive model assembly. What I did was just training for 11 times the same model, changing only the random seed, and then got the median output probability of these 11 models. This is the final result. As you can see, I reduced the false positive number of 7 units. I increased this ROC, area under the cube score, of some infinity value, and I also can increase the F1 score. Is this excellent? No, but it comes for free. It's a free lunch, so why not? This doesn't have any cost for me. Now, last thing, how to minimize the fraud misclassification error. Now, this 0.5, at the beginning I said, we will classify something as a fraud if it has probability greater than 0.5. But is this threshold the best one in our case? Spoiler, the answer is no. What happens here is that we have 102 transactions which are frauds, and we don't yet. These ones. We are only checking 905 transactions. They're classified as frauds. This is efficient because it means the anti-fraud specialist does not have to do a lot of manual work, can focus on the sum of these two numbers when he has to check transactions. But this number is still a bit high. So what I did is train the threshold on the test set in order to capture 90% of frauds. Okay, so I would start from 0.5 and lower this number until 90% of fraud is actually captured by my model. This gives me a confusion matrix which looks a lot better. It is true that on one hand, we have to check 6,500 transactions. We have something which is a little bit less efficient. But does it really matter? No, because we get this. Only 35 frauds are classified as legit. This is the most dangerous error for the bank. This is very costly, very dangerous, and we don't want to do that error. So this model is already way better than that one, way more fit to answer our question. Now, it's time to wrap up. See where we started from. We started from here, where our poor anti-fraud specialist was going to get fired, and then we did a bunch of tricks. So we handled the unbalanced data set, we did hyperparameter tuning, model and SAM, threshold tuning, and we got here. Here, the anti-fraud specialist is going to check less than 7,000 transactions. He's going to be able to identify 302 frauds, only miss 34 frauds, and maybe get promoted as well. This is my last message. What did I learn here during this model? The first thing very important is to study carefully the business issue. Is some error more costly than some other error in your context? This is very important and can really make a difference on the results you provide. Then understand the business context. So, what is the business context? What kind of data is there available? Where will your model be deployed? Do you have to be able to explain what's going on in your model, or can you build a black box? That's also very important to be able to convey the quality of your results. And in the end, I learned to accept when good enough is good enough. Because as data scientists, we always aim for perfection, and we could spend 2 weeks getting that 0.00001 increase in the performance of our model. But sometimes that is just wasted time. Last but not least, have fun, because that's the only way to do a good work. Thank you. Do you have any questions?
Yes. You didn't have the benchmark as the rule-based model that was in place before. So how was the performance of that model compared to yours?
He would, it was actually in slide 1. He would highlight roughly 5,000 transactions every day, of which only 14 were frauds. Okay. And the machine learning model is built starting from the data set, which is the output of that rule-based model.
Okay, then you're training your model to replicate what the other model did in the past with 100%. I mean,
No,
the training set, the ones, are the ones that were somehow found by the rule-based model?
No, the rule-based model would highlight suspicious transactions, and then, but then those to me would all be zeros. Ones would be suspicious transactions that a human, an anti-fraud specialist, validated as real frauds.
Okay.
So I'm starting from the output of the rule-based model, validated by a human.
Okay.
Did you get promoted?
I don't know, I can go downstairs and ask my boss.
So, a couple of things, if I may.
Yeah, sure.
The first one is, you said your metrics were the AUC and the F1 score, but then you kept talking about false negatives. So I was wondering whether you considered moving to recall instead of F1 score, since you are putting so much weight on false negatives.
The target function on which I optimized my training was the
AUC, right?
Exactly. And then I would check directly the confusion matrix to understand in what direction I should move.
Did you consider trying to train based on the recall instead of the AUC?
No.
Is that okay?
No.
Okay. And second thing, if I may, kind of look like you use like a fifth of your data set for validation, for testing or validation, right?
Yeah.
And kind of looked to me like you were sort of overfitting when you were doing the ensembling and then deciding the threshold for the say classification output. So I was wondering whether you tried this model on actual new data.
Yeah. All the results you were seeing there
wasn't that part of the
test
cross validation? Was that the last confusion metrics you showed? Was that based on the cross-validation data?
No. It's all validated on a test set, which wasn't part of the training process.
Okay, but then it was always the same one, right? The test set.
Yes.
You decided which threshold to use based on the test set, right?
Yes.
And then you presented the results on the test set, which are the best results you got
on the test.
On the test set. Okay, so I was wondering whether you actually tried this on new data that was not the test set to see whether it was any good.
No, also because I have some kind of shortage of data. I only have data from August, so it's not a lot. Minority class, it's already
no, absolutely.
And I kind of have to do my best with what I got.
So is this rolling to production?
Yes.
Okay, so you might have some new data at some point. Yeah, awesome, thank you.
And do you plan to make the slides available somewhere?
The slides available somewhere?
They will be available. We will give you in the meetup, I think, site.
Okay, thank you.
Did you consider since you are working in Python, did you consider the auto-scientific learn package? Because it's a kind of enhancement of scientific learning, but it's geared to a little bit automating the parameter search activities.
Actually, I didn't.
Okay.
I did not. I stuck to the issue package. Okay.
Last question.
Sure.
You use a supervised approach.
Yes.
So you are somehow learning something that was already a subset of the suspicious transactions.
Yes.
Have you tried or have you thought about trying any unsupervised in order to somehow discover new types of frauds that were not? Right?
Yes. This is actually one leg of a big project which has two legs, and the other leg is going into the direction of unsupervised, because we're building network analysis tool for this purpose, to identify new frauds which otherwise not even the human anti-fraud specialist would be able to see. And maybe one day the KPIs from the network analytics tool will be included as features in this model.
Another question, the kinds of the transaction in the field where bank account, bank transfer, bonifico, for example.
Yeah.
Just this kind of transaction.
Yeah, bank transfers and also online transactions. So, for instance, top up of your SIM card, contactless transaction, or everything that goes through our online channel.
Payments through on banking, any kind of payment.
Yeah. Thank you.